Welcome, pre-algebra class, to another episode of Mr. Chow Time. Today we're adding linear expressions. This is lesson 3, page 305 if you're interested. Linear expressions, we're adding them. So what is an expression again? An expression is just what's on one side of a equation, right? So this is an expression, this is an expression. This is an expression, and this is an expression. So an expression has terms and sometimes has operations, but it does not have to. The only kind of expression we're looking at is are expressions that are raised to the first power. That means it has no written powers. So you remember that powers, they look like this, right? X to the 1, x squared, x cubed, x to the 4th. Well, x to the first power, we don't write that 1, right? We just write x by itself. And so all of these are linear expressions. If we had a power in there like 2 or 3, then this is no longer a linear expression. This is now, well, it's a different kind. It's an exponential expression, you can call it. So anyway, we're not looking at any of those today. Okay, so let's add some expressions. When we're adding, remember that parentheses can be taken away or moved around by the associative property of addition if all we have is addition. And that's all we have here, right? We're just adding things together. So we can move these things around, or we can get rid of them. So that means the 3x and the 2x we can combine. Those are like terms. So this is 5x, and the 4 and the 1 we can combine also to be 5, right? Here we're also adding. We're adding some negative numbers, but we're still just adding. So if we add negative 2 and negative 4, we get negative 6x. And then 2 plus 2 is 4. All right, your turn. Welcome back. So x plus x is 2x. We have 2 x's there. And negative 3 plus negative 4 is negative 7. You could also write 2x plus negative 7 if you want. Here we have 1 negative x, and then we're adding another 3 negative x's. So that's 4 negative x's, right? And then we have a plus 1. Okay. Don't forget that a negative variable cancels out a positive variable or constant, right? So if you have, for example, a 3, and then you add a 2 to that, but then you subtract a 2, then the add 2 and the subtract 2, they cancel each other out, right? So in that same way, if we have a 3x and then we add a negative x to it, that's basically canceling out one of the 3 x's, right? So that leaves us with 2 x's. If we had 3, oops, I'm going to use green for this. If we have 3 x's, 1, 2, 3, and then we had 1 negative x, the negative and the positive, they cancel each other out, and we're left with 2. Okay, plus 2 plus 4 is plus 6. Your turn. Welcome back. All right. 8 minus 2 is 6x. 4 and negative 4 cancel out. Negative 4x plus 5x, that leaves us with a single x. Negative 1 plus negative 4 is negative 4. Okay. Let's look at some geometry examples. So the length of a side of a golden rectangle. A golden rectangle is a special kind of rectangle with a special name, the golden rectangle, where the ratio of the sides, a ratio is a comparison between two numbers, right? And the two numbers we're comparing are the length and the width of a rectangle. The ratio is 1 to 1.62. So if this was 1, then this would be 1.62. So the length of a golden rectangle is approximately 1.6 times greater, right? This side, the length is 1.6 times this, the width. So we're going to write a linear expression for the perimeter of a golden rectangle. All right, well, we don't know the width of this rectangle, right? So we're just going to call that x. Or actually, let's call it w. That makes a little bit more sense. Let's call it w. But we do know something about the length, right? The length is 1.62 times the width. So instead of writing length here, we're going to write 1.62 times the width. So now we can write an expression, right? And if you remember from other classes, that the perimeter is the distance all the way around the rectangle, right? So we have w plus 1.62w. That's one set of length and width. And then we're going to add another set of w plus 1.62w. Well, all of these are w's. They're all like terms, so we can just add them all together. Here's 1. Here's another 1.62. That's 2.62. Add another one is 3.62. And then add another one is 5 point something. Right? Yeah, 5.24 W. Right? I should check my math on that. 1.62 plus 1.62 is 3.24. 3.24 plus 2. Yep, okay, great. So to find the perimeter of the golden rectangle, if the width is 8.3. This is number 2, our second question. What if the width is 8.3? So we just substitute 8.3 into the w, right? So that's 5.24 times 8.3. And what is that? It's some number. I don't want to do it, so I'm just going to use a calculator. 8.3 times 5.24 is 43.492. All right. Your turn. Welcome back. So here we have a rectangle with the sides 5x plus 1 and 2x minus 1, right? Write and simplify a linear expression for the perimeter of the rectangle. The perimeter. So again, we're just going all the way around, right? So we're going to add these two. And then we're going to add 5x plus 1 again. And then we're going to add another 2x minus 1. Again, since we're just adding, the parentheses don't need to be there, right? We can, and plus there's nothing to simplify inside the parentheses anyway. So we have 5x and 2x and another 5x and another 2x. That's 14x. And then we have plus 1 and minus 1, and they cancel out. Plus 1 and minus 1, they cancel out. So all we have left is 14x. This is the perimeter. Find the perimeter of the rectangle if the value of x is 5.4. So 14 times 5.4, because it's saying that x is 5.4. So we just plug 5.4 into this number, and we get something, right? 75.6 centimeters. Okay. Here's your must do. 307, 308 odd. Thanks. Bye.